Welcome to my lecture. Today we are going to discuss about the shifting theorems on Laplace transform. So this theorem says that if the first shifting theorem says that if Laplace transform of ft equal fs, then Laplace transform e to the power at ft is equal fs minus a, where a is any real number. So there is a shifting on the parameter on its translation. So let's have one examples with this translation. So we know that Laplace transform of t to the power 3 and then e to the power 5t, where 5 is a, and then we'll write the Laplace transform of this whole function. So let ft equal t to the power 3, then Laplace of ft is equal Laplace of t to the power 3, which is factorial 3 over s to the power 4. Then this is fs. So here a is equal 5. So fs minus 5, Laplace transform of t to the power 3, e to the power 5t will be fs minus 5. So which is 6 over s minus 5 to the power 4. Now we'll have our next example is sine hyperbolic t e to the power 5t. So we already know sine hyperbolic t. So let ft equal sine hyperbolic t. So Laplace transform of sine hyperbolic t is equal 1 over s square minus 1. So when you take the e to the power 5t with this sine hyperbolic t, so we take this as a fs, here a is equal 5. So therefore we get it here. Laplace of sine hyperbolic t e to the power 5t equal fs minus 5, which is 1 over s minus 5 whole square minus 1. Now using this formula, we are going to find one inverse, and the problem is L inverse 2s plus 9 over s plus 3 whole square plus 4. So clearly we can see there is a shifting here. So therefore we need to introduce the shifting versions of this. So we rearrange the numerator part as s plus 3 to keep similarity with the denominator, and then we separate the factor as 2s plus 3 over s plus 3 whole square plus 4 and 3 over s plus 3 whole square plus 4. So this expression is related with the sine and cosine. So as in the numerator you have s plus 3, the variable. So therefore this will be with the cosine and this will be with sine, and we have to arrange the constant part here. And then since s plus 3, so there is a shifting here. So this is cosine 2, 4 will gives you cosine 2 s 2t when we take the inverse, but here s plus 3, so we'll have the shifting property. So therefore e to the power at ft equal fs minus a. So this is the inverse, L inverse f minus a equal e to the power at ft. So in this case a is equal 3 and a is equal 3 and this is 2. So therefore we will get it 2 L inverse. So this is e to the power minus 3t cosine 2t, and this is 3 over 2 e to the power minus 3t sine t, because a is equal minus 3.